Okay, so once again, welcome to the AMATIC 2019 webinar series. My name is Pat Riley from Hopkinsville Community College in Kentucky. I'm the webinar coordinator. Our webinar today is with Christine Franklin on developing statistical skills for school-level teachers and students. This is sponsored by AMATIC, the Teacher Prep Committee, the American Statistical Association. The views expressed by the presenters are not necessarily the views of AMATIC, and any commercial products mentioned are not endorsed by AMATIC. I'd like to thank McGraw-Hill and Alex for sponsoring the 2019 webinar series. Okay, so Christine, I will let you go ahead and switch over to sharing your files.
Okay.
While you do that, I will introduce Christine. She is the ASA K-12 Statistics Ambassador, ASA Fellow and University of Georgia Emerita Statistics Faculty. She's the co-author of 2 statistics textbooks, the Writing Chair for the ASA Policy Documents, Pre-K through 12 GAYS, and the Statistical Education of Teachers. She's writer for the recent NCTM policy document Catalyzing Change. She is a former AP Statistics Chief Reader and a Fulbright Scholar. She is crazy about running, hiking, scoring baseball games, and reading mysteries. And before I completely turn it over, we've got 2 other panelists, Julie and Mark. If you would like to just mention just a quick introduction, then we'll let Christine begin.
I'm Julie Hansen. I chair the Statistics Committee for AMATIC.
And I'm Mark Coleman. I'm the chair of the Teacher Prep Committee for AMATIC.
We lost you there, Mark. You want to try it again?
Okay, let me try this again. Can you hear me? Can you guys hear me right now?
A little bit.
Okay, I'll try to speak louder. Mark Coleman, the Teacher Prep Committee chair for AMATIC.
Okay, Mark, you're kind of fading in and out. Maybe you could just enter it in the, type it in the chat area, so
okay.
We'll find out that way. And Christine, the floor is yours.
All right. Thank you so much, Pat. Let me start the slides here. Well, first of all, I'm really excited to be with everybody today. As Pat just mentioned to you, you will be able to download a PDF of all my slides. So don't worry about taking notes. Just kind of sit back and listen. And I'm just very excited to have the opportunity to share with you my love of statistics education and what we see is really a big important role that 2-year colleges play in trying to prepare some of our future school-level teachers to deliver the statistics curriculum. So what I'm going to talk about today is why that's important, but also give you some highlights of one of our documents from ASA, which is called the SET document. It's the Statistical Education of Teachers. And let me just mention that this document you can download from the ASA website, and I'll be giving you the link to all these resources from ASA later on in the slide presentation. So I guess what I'd like to start out by talking about is just making everyone aware of just how we're surrounded by data and how data is everywhere. I always like to use my slide with the Apple Watches because I'm very addicted. I have an Apple Watch. I also have a Fitbit. So I like to wear 2 fitness devices and collect lots of data on myself. I just ran a half marathon on Sunday, and I earned new badges with my Apple Watch, which kind of motivate me to really try to take care of myself. But I'm also very competitive. But I guess the main thing that we need to think about is how much data we generate every day, how much our students generate every day. I think about the social media. I mean, the social media, of course, is in the news here lately, especially Facebook and the postings that Facebook make. But it's very interesting that when we talk to students, I think that students really don't ever think about how much data they generate every day, how much data you and I generate every day. The latest information that I could find about how much data an individual generates every day is it's estimated that an individual generates on average close to 1 gigabyte of data each day. Just think about that. That is a lot. And in 2018, there were 3.7 billion internet users. And that was a 7.5% increase over just 2016. So think about how much data you're generating every day. Think about where that data is going, and think about how that data is being used. And this is what we need to try to help our students, even at a very young age, process and then learn how to make good decisions about that data. So I guess what I'd like to think about, have us all think about today, is that as statistics educators, I really feel like we're at a crossroads right now. We're at a crossroads where in teaching statistics is no longer about teaching that data is numbers in context. Data is no longer just variables that we classify as either quantitative or categorical. Data is no longer numbers that we store in a static spreadsheet, like an Excel spreadsheet. But now we're faced with encountering data that's sounds, that's images, that's text data, Twitter data. How do we deal with all of this non-traditional data and make sense of that data? So not only as statistics educators are we still faced with trying to help our students learn sort of the foundational skills that we've been teaching for many years, but now we have all of this new non-conventional data that we need to help our students make sense of. So we're at the point to where we need to think about how do we help our students become data savvy. And this is not something that needs to begin at the college level. This is not something that can happen in one introductory statistics course that we teach at the college level. This is something that needs to begin in kindergarten, and we need to help these students evolve through the years in their statistical thinking. I like to say, and I know I'm very biased, but I believe in today's age that becoming data savvy and data literate is as fundamental for our students as learning how to read and write. And it must begin in the early grades. I think it's very interesting that last week there was an editorial that came out. I saw it first in the Los Angeles Times, but I think it's appeared in some other media sources now. But this was an article by Joe Bowler and Stephen Levitt. And I thought there were some very pertinent pieces to this editorial that they wrote. One of the statements that they made was, what we propose, and by the way, Joe Bowler is just a very well-known internationally math educator from California, and Stephen Levitt is at the University of Chicago and connected with Freakonomics. But what we propose, they said in their article, what we propose is as obvious as it is radical, to put data and its analysis at the center of high school mathematics. Every high school student should graduate with an understanding of data, spreadsheets, and the difference between correlation and causality. Moreover, teaching students to make data-based arguments will endow them with many of the same critical thinking skills they are learning today through algebraic proofs, but also give them more practical skills for navigating our newly data-rich world. And I thought that really sums up nicely what we're trying to promote at the school level. But in order for this to happen, we have to be able to have our teachers prepared to teach these students. So I thought what I might do at this point is give you some numbers, because I know most of you like mathematics and like statistics. So I thought I'd give you 5 numbers. And I'd like for you to take a couple of minutes and think about what these numbers might represent. In other words, what story might these numbers tell? So I'm going to give you 2 minutes to think about this. So I'll give you about 30 more seconds. So I know that we can't really have you speak out right at this moment with your choices, but I would guess that maybe many of you were looking for a pattern in these numbers, maybe to see what kind of story you might have.
Christine, do you want them to people to type in the chat window?
That would be great if they
Okay,
could
so
type into the chat window what they were thinking.
yeah, so if anyone wants to share their thoughts on the numbers, just go ahead and enter it. Make sure you have it to all panelists and attendees so that we can share with each other.
Will I be able to see those, Pat?
Yeah, if I'm not seeing any yet, I'm guessing that's, I don't know if people are just typing a lot or they didn't come up with a story for the numbers, or here we go.
They probably have long stories.
Yeah, maybe they're writing stories. Okay, here's a couple. Did not come up. Okay. Yeah, I forgot. Christine, if you hit the, since you're presenting, it doesn't show the same. If you press the chat at the bottom, you'll see the chat window, but it'll be right on, it'll be covering up your PowerPoint. So you might want to just if you want to see
Yeah.
some of the things we've got in there. If you don't want to do that, we've got some answers like,
Yeah, what are some of the answers? It might
okay,
be.
so one person said it's like a story, like one person invited 2 friends and they peeled 22 apples and they started telling the story like that.
Oh, I love
Someone
that.
said they were thinking of the number of people that were involved in a news article on the front page. We have one said maybe it was an invasive species, some sort of trap that was put out that slowed the growth a bit between 22 and 43.
Great.
We had some kind of a geometric sequence like Fibonacci,
Right.
bacteria growth. And just for those in the people attending, one of the weird things about Zoom is while Christine is presenting her PowerPoint, she can't see the chat window clearly. It's kind of a weird that everybody can see the chat, but she can. So that's why I was mentioning to her.
Those are excellent. And this is what I would this is what I'd like to sort of throw out there. This is what you'd like for your students to be able to do. Give them give them a set of numbers like this and have them think about what are possible contexts that could go with these numbers. And these are wonderful. I really like the stories that I'm hearing. But I'm going to go ahead and tell you what I intended for these numbers to mean. How's that? Okay, so this is what these numbers actually represent from the reason I put them up here. The number 1 is actually a statistician is the best business job rank in 2019. And this information here that I'm giving you, the number 1 and the number 2, is from the U.S. News and World Report, Best Jobs for 2019. A statistician is the best overall job rank. It is also, number 2, the best STEM job in 2019. The 22 represents that there was a 22% increase in statistics degrees from 2016 to 2017. These are undergraduate statistics degrees. The 43 represents that there were 43% females that earned statistics bachelor's degrees in 2017. And that's a number that I'm quite proud of to see, that statistics is one STEM area where we're really having a high percentage of females go into this field. The 626% represents that this was the increase, the percentage increase in statistics bachelor's degrees from 1987 to 2017. So I think these are pretty impressive numbers, pretty compelling numbers to help students understand that it's very important to be able to reason statistically by the time they graduate from high school. Future jobs are in statistics. And I think it's interesting, there was in this article by Joe Bowler and Stephen Levitt, they made the following, they had the following paragraph. We surveyed 900 Freakonomics podcast listeners, a pretty nerdy group, we must admit, and discovered that less than 12% used any algebra, trigonometry, or calculus in their daily lives. Only 2% use integrals or derivatives, the foundational building blocks of calculus. In contrast, a whopping 66% work with basic analytical software like Microsoft Excel on a daily basis. And what I think this tells us is that we need to think about what do our students need when they graduate from high school, before they go on to college, university, before they go into the workforce. They definitely need those mathematical skills, but just as important, they need those analytical skills from being able to reason statistically and work with data. One of the things I did want to mention before we move on is that, of course, we've had some success at the high school level, and that success has been AP Statistics. And it was in 1997 that AP Statistics became a reality. This is just a graph to show you the number of AP exams from 1997. Now this goes to 2017. 2019, as I recall, last year was around 220,000, so it's been another increase of about 3,000 since 2017. But you can see there's been a very nice linear increase in the number of AP Statistics exams. AP Statistics has been quite the success. But what we have to remember is that's only a small percentage of our high school students that graduate that take AP Statistics. And what we're trying to advocate for is that all students, when they graduate from high school, have that statistical ability, that statistical foundation that we want. So the first document I thought I would mention before I talk about SET is the GAZE framework. Now this is not the college GAZE. This is the GAZE that was written for pre-K through 12. It has very much the same spirit as the college GAZE. And like the college GAZE that I think many of you are probably familiar with, this is built around the statistical problem solving process, which is the 4 steps of formulating questions, collecting data, analyzing your data, and interpreting your results. And as you will see, with each of the 4 steps of the statistical problem-solving process, we also talk about variability. And at the first step, it's anticipating variability. For collecting data, acknowledging variability. For analyzing data, we account for variability. For interpreting results, we then acknowledge variability. But one of the big things that the GAZE framework tries to help with is to differentiate what are the differences between mathematical and statistical thinking, but also what are the similarities between mathematical and statistical thinking. Especially for our teachers who have primarily been trained in mathematics, this is very difficult for them to think about how to deliver the instruction and the pedagogy that's necessary with the statistics standards because they're used to mathematical thinking. And how does that differ from statistical thinking? So what I tried to do here was to put up what I saw as some differences, but also what are some similarities. So let's think about what are some differences between mathematical thinking and statistical thinking. Well, one of the things that I like to say is that when I think about mathematical thinking, I think about where's the proof. And when I think about statistical thinking, I think about where's the data. Also, we have inductive versus deductive reasoning. So with statistical thinking, we have inductive. With mathematical thinking, deductive reasoning. With statistical thinking, we're acknowledging, we're anticipating, we're accounting for, and we're allowing for variability in the data. We're also very focused on context with statistical thinking. And another big difference is that with mathematical thinking, it's more deterministic, but with statistical thinking, it's more probabilistic. But then think about the similarities between the two. They both involve problem solving. They're both about precision, but maybe precision in different ways. They're both about modeling. They both look for structure. They both use tools appropriately and strategically. They both are about critiquing arguments and the reasoning of others. And they're both about looking for patterns. So I think it's really important that we help our teachers understand that there are similarities, but there's also differences. And then how do we help our students understand those similarities and differences? So in 2012, this is when the Common Core came out. And the Common Core was the first time in the United States that we had anything close to a national curriculum in school mathematics. Even since the Common Core, our 50 states still pretty much individually have their own standards, but more and more states now are focusing their standards around recommendations from the Common Core. When the Common Core came out in 2012, statistics had a predominant presence in middle school and high school. Now, unfortunately, not as much went into elementary. Many of us in the statistics education area weren't happy about this, but we were very happy to get what we got at the middle school and the high school level. So you'll notice that at the middle school level, if you look at the topics here, that middle school students should have some experiences with before they go into high school, you'll notice that many of these topics are what you're currently teaching in your introductory statistics course. And then when you look at the high school topics, of course, you see even more of the topics that you're teaching in your introductory statistics course. Now, the Common Core curriculum was set up to where in the high school level, when you get to inference, inference is based upon using simulation-based methods, like randomization tests, for example, or maybe bootstrapping with confidence intervals. So probability distribution-based inference is not what you'll see in the regular mathematics curriculum for the statistics standards. I should also mention that not only now are statistics standards in the mathematics curriculum at the school level, but the high school science standards also now contain statistics standards for the science curriculum. And interestingly, the mathematical practices, which I'll talk about in just a moment with the mathematics curriculum, and this is more about your processes and your habits of mind that you form when you're thinking statistically and mathematically. The mathematical practices are now also emphasized in the science standards, the high school standards. So I think at this point, I guess what I would like to emphasize is that we really have an opportunity. We have some huge opportunities to try to develop statistical literacy for all of our students before they graduate for high school, before they go out into the workforce, or before they go to the college and university level. But the huge challenge that we have ahead of us, first of all, is being able to prepare our teachers to deliver the statistics standards that are advocated for in the Common Core curriculum, and also implementing statistics and data science in all of our classrooms, not only the mathematics classrooms, but also the science classrooms and other fields within the school level. So I'm here to talk about how teacher preparation really must be a priority at the university level, the college and university level. And one of the things that ASA felt that was important is after the Common Core curriculum came out and there was an abundance of statistics standards, that it was important to try to help teacher preparation schools or colleges and universities that are preparing our future teachers understand what's needed to get our teachers ready. And so this is when the Statistical Education of Teachers document was written. You'll notice that there were several recommendations. I just picked a few of the recommendations for you to see. First of all, there's the recommendation that a deep conceptual understanding of the statistics they will teach and to develop the habits of minds for practicing statistics. That's a lot for our teachers to try to develop when most of them had had no exposure to statistics until they take that first introductory statistics course. A statistics education community that includes statisticians is one of the many constituencies committed to working together to improve statistics instruction at all levels and to raise professional standards in teaching. And then finally, an introductory course that covers and models the pedagogy the teachers will use at the school level. And I think it's this last recommendation that I have listed here that is so essential when we think about those of you in the two-year college community, because statistics show that so much of our introductory statistics courses are taught at the two-year college level. And so think about how many students you have in your classrooms right now that are future teachers. And the only statistics course that some of those students may see before they go out to the school level to teach these statistics standards is being taught in your schools. So this is where we're advocating. It's so critical that we think about how we actually model and teach our introductory statistics courses. So the format of the SET report, I just wanted to put this up here. The SET report you can download as a PDF from the ASA website. And I'll have that, I think that link was for you in the abstract that you received, but you'll also receive it later on in the PowerPoint. But as you can see here, there's 9 chapters, and there's an appendix of examples that you can look at. There's 12 examples in the appendix. I'll talk about the appendix first. The appendix has 12 scenarios, and what we did is we identified 4 themes that we thought were very common areas where misconceptions happen with students in developing their statistical thinking. And I think as you read these, if you are teaching statistics courses, you will probably recognize that, yes, these are areas that maybe students in your courses struggle with when you're teaching those key statistical topics. So question design alignment, connections between data type, numerical summaries and graphical displays, proportional reasoning, and then the role of randomness. Within the document, there are 3 chapters for each of the school levels that we call elementary, middle, and high school. So what we do is we talk about what is it that our elementary teachers need, what do our middle school teachers need, and what do our high school teachers need in terms of content. And in each of those 3 chapters, the examples are built around that 4-step statistical problem-solving process. There is a chapter, this is chapter 3, that is focused around the mathematical practices. Now, if you go to the Common Core website, you will find that there are 8 mathematical practices. And with those 8 mathematical practices, there are mathematical descriptions for what each of them means. What we did in the set document was to take those 8 mathematical practices, and then we rewrote a description for each practice through a statistical lens. And essentially, the mathematical practices is what we like to think of as developing your habits of mind. As a practicing mathematician or a practicing statistician, you know, how do you reason? How do you process? How do you practice mathematics? How do you practice statistics? So what I decided to do for this presentation was to pick just one of the 8 mathematical practices. And the one that I picked was mathematical precision. So if you'll notice, under the mathematical precision, I tried to summarize with bullet points what the Common Core gave as the mathematical description for this particular practice. So they talk about how it's important to communicate precisely to each other. They talk about how it's important to use clear definitions and state the meaning of symbols. They talk about how it's important to specify units of measurement and label axes. It's important to calculate accurately and effectively and express numerical answers with a degree of precision appropriate for the context. And they talk about how by high school you need to learn to examine claims and make explicit use of definitions. Now, I think as we look at that and think of ourselves from a statistical standpoint, you know, I think as we practice statistics, we would all agree that those bullet points are very important for us in statistics as well. But then, when we think about precision in statistics, I believe that not only are these very important, this mathematical precision, but this is how in the set document we further expanded statistical precision. So when we think of precision in statistics, we also think about how one must be precise about ambiguity and variability. In statistics, students must understand the statistical problem-solving process. It begins with the precise formulation of a statistical question that anticipates variability in the data collected that will be used to answer that question. In statistics, precision is also necessary in designing a data collection plan that acknowledges variability. Students are precise about choosing the appropriate analysis and representation that accounts for the variability in the data. And students can transition from exploratory statistics to inferential statistics by using a margin of error to quantify sampling variability around a point estimate. Students recognize the precision of this estimate depends partly or partially upon the sample size. So one of the things that we have found in professional development with teachers is these mathematical practices, when teachers examine these practices, first of all through a mathematical description, but then examine them through a statistical description, this actually helps them to understand the differences in mathematical and statistical thinking, but at the same time, it also helps them understand the similarities. And it allows them to better deliver the content in their classroom. So we are big proponents of using these mathematical practices. The other thing that the SET document talks about, which I think is important at the school level, but also important at the collegiate level when we teach statistics, is assessment. And I think we can all say that maybe we're guilty of not thinking enough about assessment when we teach our courses. It's very easy to let assessment be sort of that last minute thing that we do in teaching our courses. We are so diligent about preparing before we go into our classroom and what we do in the classroom, but then when it comes to the actual assessment that we give our students, I've found myself very guilty of, I should have thought about this sooner. I should have thought about this more upfront than what I have. And assessment is quite the big deal at the school level. As we probably are all aware, there's some very high stakes tests that our students have to take at the school level, and our teachers are judged by the performance of their students on these high stakes tests. The other thing that we have to be very aware of at the school level is that assessment can drive what the teachers do in the classroom. So if teachers know and administrators know that a high stakes test that the students are going to be taking is only 10% statistics items, statistics and probability items are only 15%, then they may make the decision not to cover that content in their classes and instead focus maybe on algebra and geometry. So we have the issue that we need to have a higher percentage of items on the test that focus on the statistics and probability, but even more important, we need for those items to match the content that we expect the teachers to be delivering in the classroom. And so we're still having an issue with a mismatch between the types of items that are appearing on the high stakes test and the ideal type of items that we'd like to see. But that is getting better. So I don't want to give all a negative, but I do think assessment is very important to think about. I thought I might give you this particular assessment item to look at. This was an item that was on a praxis test. The practice exam, of course, is what many teachers, school level teachers, have to take within the state that they're in to get certified to teach. So it's a teacher certification, state teacher certification exam. This item that I'm showing you right here was labeled a statistics item on the praxis exam. And you might look at it, and I suspect most of you could probably work through this, come up with the answer. And I'll go ahead and tell you the answer. The answer is D. It's 12. But think about, do you really think this is a statistics item? Did you use any type of statistical reasoning to answer this question, this problem? I suspect you didn't. You basically used proportional reasoning, correct? That you use mathematical reasoning, mathematical thinking. Now, why was this labeled a statistics item? I think it was because it had a pie chart, it had a graph, and it did have some context. But you really did not have to use any statistical reasoning to answer this question. This was really a mathematics problem. Now compare that to this item. So a school is planning a field trip to the aquarium or to the zoo for students in grades 6 through 9. There are 100 students in each grade level, and every student was asked which place he or she would prefer to visit. The bar graphs for the 4 grade levels are shown below. In which grade level did the responses vary the most? And the responses are, of course, you either choose to go to the aquarium or you choose to go to the zoo. So I'll go ahead and give you the answer. But before I do that, do you feel like in this one you were having to use some statistical reasoning? Was this a mathematics problem? Do you feel like you were using mathematical reasoning or statistical reasoning to answer this? I'd like to think that you were using more statistical reasoning because you were having to think about variability in this one, trying to measure variability. In which grade level did the responses vary the most? The actual answer is grade 7. The grade that the responses varied the least was grade 8. Now notice the reason grade 7 was the one where they varied the most. 50% said the zoo, 50% said the aquarium. Where are you going to have the most difficult time trying to decide which place to go, the aquarium or the zoo? Well, grade 7, because there's more variability in the students' answers. In grade 8, there's less variability. There's more consistency. It's clear that most of the students prefer to go to the aquarium compared to the zoo. So we would like to see an item more like this that's labeled a statistics item where they're having to think about the variability than the previous item, which is really just a mathematics problem. Now, I'd like to tell you about a wonderful website that you can go to access many statistics, well-written statistics items that we think are models for the school level, and that is the Locuseppe website. And so if you click on this link, you will find several multiple choice questions, free response questions, very much similar in the spirit of the AP statistics questions that you oftentimes see that can be used at different grade levels. So this is a wonderful resource for you. I would also like to tell you about these resources that are from ASA and NCTM. This is our collaboration with the Joint Committee. And we have a journal called the Statistics Teacher that is open source. You do not have to be a member of ASA to access the Statistics Teacher. So for all of these resources that I just showed you right here, all you have to do is go to amstat.org and then go to the education menu and you can access all of these. The other thing that I'd like to mention is what's going on with this graph. This is a collaboration that we have with the New York Times. It has now started back up for the new school year. It's once a week. So if you just Google what's going on with this graph, I highly recommend. And coming soon in 2020, some pretty exciting resources. The Pre-K through 12 GAZE framework, the update from the 2007 version is coming out in April of 2020. There's also going to be a book for teacher educators that will be coming out in 2020, and also a new modeling book of investigations for high school. And many of these investigations would be very appropriate to use in your introductory statistics courses as well. I also wanted to mention many of the collaborations that we have going on nationally. You'll notice we consider AMATIC one of our very strong collaborations. We're very proud of that collaboration. We also collaborate with NCTM, the National Council of Teachers of Mathematics. We collaborate with the National Council of Supervisors of Mathematics as well. And we have a collaboration with the Association of Mathematics Teacher Educators, AMTE. We also have some collaborations internationally. We work closely with the New Zealand Statistics Education Committee, which is very active in New Zealand at the school level. They're actually doing some wonderful things right now at the school level with data science, which I think are going to have a big influence on what happens here in the US at the two-year college level as well as the school level. And we have also been part of the International Data Science in Schools project. That curriculum is now I think it has been released, which can be used for teaching data science in the high school. So in conclusion, I'd just like to leave with these points. Statistical literacy is for all, and we really believe strongly that it must begin at the school level. It should begin at the kindergarten level. We also want to emphasize that questioning is essential throughout the statistical problem-solving process, that it is so important that we help our students become healthy skeptics of statistical information. And I always like to point out that statisticians are not data crunchers, but instead we're problem solvers. And becoming a problem solver, as you well know, even in mathematics, is a skill that can't be developed overnight, that it has to evolve through the years. And I wanted to leave some food for thought as well. The food for thought that I wanted to leave at K through 16 is the collaboration that's needed for teacher preparation. It's very easy to say that we need more teacher preparation for our school level teachers, but what does it take to provide that essential preparation? It takes collaboration. How can we form those collaborations? We need more research in statistics education, especially at the school level. There's been a lot of research recently in years past at the undergraduate level, but we need to see more at the school level. And how do we catch up with the data and statistical literacy expectations that are at the post-secondary level?
I'll be fine.
So I wanted to leave you
I'll
with
do
this
it.
video.
Well, here goes something, I guess. Well, okay, you can do this. I'm gonna jump.
You got it.
Whoa, my ski's slipping off.
Just remember, never snowplow, okay?
No snow plows.
Keep it straight, you'll be fine.
Okay.
Same thing on the 20.
Straight. Do you go faster on the end run?
Little bit.
A little bit?
Yeah.
Is it any steeper, do you think? Not much?
Same steepness, it's just longer.
Well, just longer. Just longer. Just a bigger 20, that's all.
Yep. Have
It's a
fun.
bigger 20. Go ahead. You got this. I got it. It's fine. No. You'll be fine. Okay. Here. The longer you wait, you'll be more scared. I go. Yeah. Just the suspense at the top with the first time freaks you out. That's the only thing. It's so fun. Huh? 60 seems like nothing now. Whoa!
So I love that video because so many of the school level teachers that I work with say to me, I can't teach statistics. I don't have the confidence. I don't have the background to teach statistics. And my response is, yes, you can. Take the risk. And then 2 years later, they'll come and say, you know, I love teaching statistics. I love teaching the statistics unit. This is what my kids love. Take the risk. And I think that's what we have to do as teacher educators as well, is take risk and really push ourselves to try to help develop those teachers to teach at the school level. So thank you so much for the opportunity, and I'd love to answer questions. Whatever you might want to comment, anything.
Okay, can we thank Christine for the webinar in the in the chat section if you want to leave a comment, or if you have questions now, this would be a good time to ask the questions. Christine, if you want to stop sharing, then you should be able to see the questions.
I'll stop the share here. Let's see.
And that'll be easier than me trying to just read them all to you.
How's that?
Well, let me finish up.
Okay.
So just real briefly to finish up, thank you for coming. Thank you for your interest in AMATIC and the webinars. If you're not a member, you can join at the AMATIC site. We also are on Facebook, so if you want to join the Facebook page, you get a lot of good information about everything AMATIC. Outside of the webinars and traveling workshops, there are national conferences. The Milwaukee conference is coming up soon. There is an opening for a professional development coordinator. I think they're close to filling that, but if that might be something you're interested in, or other positions in AMATIC, again, please check the website for details under the Get Involved. We'll try to get this posted as soon as possible. It may take a week or two, depending on when we can get all the materials. And then if you would take a few minutes to evaluate this webinar, you have a link there on the screen, and also the QR code if you want to go directly to it. I'll leave this up here for a moment. And then Christine, if you can see the chat questions now and want to.
Let's see, can I put up, tell me, I'm sort of technology challenged sometimes here. Do I just push the chat button?
Right, and you should see the chat
okay,
over on the side.
Gotcha.
And again, I'm presenting, so I can't see what you all are seeing right now. Okay, there we go.
Here's one about cutting down the other content of math courses to get more statistics at the school level. One of the things that I think we're hoping that will happen is that teachers can become more comfortable maybe with actually using data to drive the teaching in some of the traditional mathematical topics. So kind of more of an integrated approach to teaching the mathematics curriculum. So not necessarily that you have a separate algebra unit, separate geometry, separate statistics, but there's more integration of the mathematical topics.
So there was one question about certificates. If you, when you take the survey, the last question asks if you want to get a certificate and give your contact information there. Christine, there was another question a little further up. It was a bit longer. It says, in teacher preparation programs, teachers are required to take an abundant amount of math education courses.
Yes.
But I wonder how many statistics education courses they're required to take. Or teacher prep programs have a lot of math ed courses. Do you know of any colleges or universities that offer statistics education courses?
Actually, I do. I have one in my backyard, which is the University of Georgia. I can attest to that. A lot of what is currently available depends upon the teacher preparation program. There's some teacher preparation programs across the nation that are starting to integrate more statistics education type courses in their curriculum. I think it's been very, very helpful to work with the Association of the Mathematics Teacher Educators, the AMTE Association, because that has really helped to bring an awareness to mathematics educations of the importance of getting more statistics in the teacher preparation programs. So I think with time, we're going to start to see even more. But yes, many teacher preparation programs are at least starting to require their future teachers to take 1 or 2 statistics courses as part of their curriculum.
Are there any other questions from the audience? You can enter in the chat.
Well, I like the what they thought about with the numbers. I'm seeing those now. Now that I'm out of the slides.
We did get one more question. Is there already an established statistics data science curriculum that schools are encouraged to adopt? And if so, is it grade specific?
There's not in the United States. There is the Common Core standards, of course, but in terms of data science, there's not a specific data science curriculum. There is in New Zealand actually right now. They've been able to implement some data science standards into their high school curriculum. But one of the new GAZE document that we're working on right now, the pre-K through 12 framework revision, one of the things that we tried to do in that document is to illustrate through examples at the different grade levels how you can incorporate more data science type focus with working with data using the current statistics standards. So there's going to be resources out there that can be used, but as we well know, it takes time for states to revise their standards and to formalize things. But we certainly are going to be trying to promote more data science ideas at the school level.
And there was a follow-up to that. Do you know if any states are currently leading the developing the curriculum?
There are states, the Catalyzing Change document that came out from NCTM 2 years ago, no, 1.5 years ago. My years are running together. This is a really nice document to look at. The Catalyzing Change document for high school essentially recommends that there be a common curriculum for 2.5 years in high school for all mathematics students. And it also recommends that statistics and probability, that strand, have equal weighting with algebra, functions, and geometry. And they actually recommend a potential pathway that high school students can take that's called the statistics pathway. So I do know that there's some states, Alabama is one of them, which is where I'm going to be, unfortunately, during the AMATIC conference at their state conference. They've just gone through revising their high school math standards, and they tried to follow the recommendations of the Catalyzing Change and getting more statistics into their curriculum. So I know that Georgia is working on revising their mathematics curriculums right now, and they're also going to be working to get more statistics into their school level standards than they already have. So I think with time, states are going to start doing this. California, I think, my understanding is that they're starting to look more closely at the statistics and data science, getting more incorporated there as well.
Well, Christine, thank you again for the wonderful webinar, and Julie and Mark, thanks for being here. Thanks for all who attended. We will get this uploaded and posted along with the PowerPoint, hopefully within the next week. and you'll receive a notification when that's been posted. So thanks again for attending, and hope you can stay tuned to more webinars that are coming up. We'll have some good ones already lined up for 2020.
Don't hesitate to email me if anyone has any questions or wants to know more about resources, whatever the case might be.
Okay, thanks again, everybody. I will stop the recording and